Another problem. An electric heater consuming 1000 watts power is immersed in 1 kilogram of water. Temperature of water rises by 6 degrees Celsius in 1 minute. If the specific heat capacity of water is 4.2 into 10 raised to 3 joule per kilogram per Kelvin, finds the percentage energy radiated out by the heater during 1 minute. That is the question. Now, heat absorbed by water to raise its temperature by 6 degrees Celsius. You can find out it's using this formula Q equals mc delta T. M is 1 kilogram, specific heat C is 4.2 into 10 raised to 3. Temperature change is 6 degree. Change in temperature 6 degrees Celsius means in Kelvin also the difference will be 6 Kelvin. When you take difference in temperature, you can use Kelvin or Celsius without changing the number. So this is heat, and the answer is 25.2 into 10 raised to 3 joule. This is the heat absorbed by water. Now, energy released by the heater, its power is 1000 watts. So in 1 hour, 1 minute, power is energy by time or work by time. So energy or work equals power into time. So energy released by the heater in 1 minute or 60 seconds equals 60 into 1000 into 60. Power into time, that is 60 into 10 raised to 3. This is the total energy supplied by the heater, and this is the energy received or absorbed by water. So what is the difference in these two, with the difference between these two? So that difference in energy is released as or radiated as heat energy. Radiated form of energy is difference between these two, 60 into 10 raised to 3 minus 25.2 into 10 raised to 3. That is 34.8 into 10 raised to 3. This is the amount of heat released in the form of radiant heat. Then what is the fraction of the total energy radiated out? That is radiant energy by total energy supplied. 34.8 into 10 raised to 3 divided by 60 into 10 raised to 3. That is 0.58. If you want to express it in percentage, just you multiply it by 100. So 0.58 into 100 or 58%. That is the percentage energy released in radiation form. Another one. Two uniform rods of same length and equal cross section are joined end to end to form a single bar. One end is kept at 0 degree, theta degrees Celsius, while the other end at 0 degrees Celsius. If the thermal conductivity of one is twice that of the other, what is the temperature of the joint at the steady state of conduction? That is the question. See this. This is one rod, this is second rod. These are joined together. Same length. The conductivity of this is K1 and this is K2. This end is at theta degrees Celsius, this end is theta 0 degrees Celsius. Let the temperature of the joint, let it be theta 0. At the steady state, Since heat cannot stop, it is flowing by conduction. So heat conducted per second by this bar must be equal to heat conducted by this bar per second. So you can use the law of conduction. Heat conducted by first bar is K1 into A into theta minus theta 0. Because the two ends are one end is at the one end of this bar is at theta degree, the other end is at theta 0. For the second bar, hot end is theta 0, the cold end is 0. So here theta 0 minus 0, here theta minus theta 0. So equate the two. K1 into A into theta minus theta 0 by L equals K2 into A into theta 0 minus 0 by L. A by L would go. Then K1 theta minus K1 theta 0 equals K2 theta 0. This is 0. From which you can find theta 0 equals K1 theta by K1 plus K2. But it is given K1 is twice K2. So you substitute here. Then theta 0 equals, in the place of K1 you put 2K2 into theta by K1 is 2K2 plus K2. That means this is K2 and K2 would go. Then you get 2 by 3 theta. It is the junction temperature. But you can do it in entrance exams or competitive exams by remembering this formula. Temperature of the junction of two rods of same length and same area of cross section, T2. I have given it to you. T junction equals K1 T1 plus K2 T2 by K1 plus K2. Here K1 is take 2K2, T1 is theta, T2 is 0, and Tj equals theta 0. You will get the same answer. Another question. You are given a graph here. The axes are temperature axis and volume axis. Identify these processes. That is a question. 1, 2, 2, 3, 3, 1. Now, general equation of a gas is PV equals RT. Now, 1 to 2. Here T is 1 to 2. This is 1 to 2. 1 to 2, 2 to 3, 3 to 1. 1 to 2. This is a straight line. That means V is proportional to T. If V is proportional to T, P must be a constant. R is always a constant. Here, for a straight line graph, the two coordinates must be proportional. So here V must be proportional to T. That means P must be a constant. So this 1, 2, this graph represents an isobaric process. P is a constant. This is an isobaric process here. Pressure is a constant. Moreover, volume is increasing. Volume of this point. This volume at this point is this. So volume is increasing. That means 1 to 2 represents isobaric expansion. Next is 2 to 3. 2 to 3 means volume is constant because this is parallel to the temperature axis. That means this represents an isochoric process. Volume is constant, V is constant. At the same time, temperature is increasing. Temperature is decreasing. 2 to 3. Arrow is towards this. Temperature is decreasing. So this represents isochoric cooling. Temperature is reduced. Volume is constant. That means isochoric cooling. That is process represented by 2, 3. 2 to 3. Finally, 3 to 1. 3 to 1. Here T is constant because the graph is straight line parallel to the volume axis. T is constant. So this represents an isothermal process. At the same time, volume is decreasing. So this represents isothermal compression. Volume is decreasing. Isothermal compression. So thank you. Please subscribe the channel and get benefit. Okay, thank you.